So number 10 says solve the equation sine of theta equals 0.3 to the nearest tenth. Use the restrictions 90 degrees is less than theta less than 180 degrees. So we're thinking about on our unit circle, we are looking in quadrant 2. So we've got our unit circle here, and we're looking just in this quadrant here. So in order to solve this, we have to do the inverse sine. Sorry, I'm in shape mode still. Let me go back out of that. So the inverse sine of 0.3 gives us our angle theta. When we plug that into our calculator, we end up with 17.5 degrees equals our angle theta. Now, one problem with that, 17.5 degrees is in quadrant 1. It's like over here. And folks, we don't want to be in quadrant 1. We want to be in quadrant 2. Let me zoom in on this a second. So that gave us an angle in quadrant 1, but again, we want to be in this light green area over here. In order to do that, we got to look at where else the sine is going to be positive, because the sine of whatever this mystery angle is positive 0.3. Going through on our unit circles, so we've got, again, our x values are our cosines, our y values are our sines. So in quadrant 1, the cosine is positive, the sine is positive. In quadrant 2, cosine is negative, sine is positive, just because they're the x and y coordinates. In quadrant 3, they're both negative, so the x and y, sine or cosine and sine are both negative. And in quadrant 4, the cosine is positive, the sine is negative. So we need to figure out where else the sine is going to be positive. So it was positive in quadrant 1, it's positive in quadrant 2. I mean, that was already part of our restrictions anyway. So what we got to pay attention to now is using this as a reference angle. It's going to have a mirror image on the other side. So this angle that I just drew right here has a size of 17.5, but it's not in standard position, so it's actually going to be 180 degrees minus 17.5 degrees, because it's 17.5 degrees away from 180. So that brings us down to 162.5 degrees. And that's our final answer.